In 2018, Ant Financial reached a valuation of $150 billion. The firm served over 700 million users, with a headcount of fewer than 10,000 employees. For comparison, a traditional 20th century bank requires an army of hundreds of thousands of human workers to process only a fraction of that data volume. This gap highlights the operational bottleneck of the traditional firm: human intervention sitting directly on the critical path of product delivery. Relying on human decision-making for routine execution creates a rigid mathematical ceiling on an organization's capacity to scale. Modern enterprise growth is restricted by the physical limits of human cognitive processing, even when capital and market size are abundant. These restrictions lead to strategic collisions. Digitally native platforms are entering and dismantling traditional industry segments because they operate without human friction. This chart compares the value delivery versus operational cost trajectory of a traditional firm against an AI-centric firm. The traditional firm's growth curve flattens because of the friction involved in scaling human labor and bureaucratic processes. An AI-centric firm breaks past that ceiling, scaling exponentially without a proportional increase in operational cost. To achieve this growth, a firm must excise human intervention from routine execution. It must replace its operational core with an automated decision engine, the AI factory. Using AI as a peripheral tool is not enough. The organization must rebuild its entire operational core as an industrialized, automated system. Many legacy companies struggle to deploy AI despite massive budgets because of architectural inertia. Architectural inertia is the rigid resistance established firms have to changing their structures due to deeply entrenched routines. This failure is driven by Conway's law, which states that organizations design systems mirroring their internal communication structures. Siloed management creates siloed software. This results in fragmented data pools, starving AI algorithms of the broad context needed for accurate predictions. Because of this mirroring, AI initiatives often remain trapped as localized, disconnected pilot programs. To build a truly modern AI architecture, a company must first completely dismantle its legacy human communication structure. In 2002, Jeff Bezos issued an internal mandate that provided the blueprint for establishing a modular digital foundation. The mandate required all teams to expose their data and functionality exclusively through standardized service interfaces, or APIs. An API is a set of rules that allows different software applications to communicate with each other automatically. This shift forces a company to centralize its data assets while distributing its operational execution. Modular architecture moves IT from a support function to the literal operating core of the business. Standardizing internal communication is the prerequisite for plugging an AI decision engine into the center of the firm. The AI factory is an industrialized cycle built on 4 technical pillars. First, the data pipeline ingests, cleans, and secures raw enterprise data. Second, algorithm development uses feature engineering to turn this data into predictive logic. These algorithms manage the explore-exploit trade-off, balancing known patterns against testing new variables. The third pillar, the experimentation platform, tests hypotheses safely. Finally, the software infrastructure deploys these tested models at scale. These 4 components work together to remove human management from the execution of daily tasks. The AI factory industrializes decision-making in the 21st century, just as the assembly line industrialized physical production in the 20th. Netflix illustrates this architecture through datafication. Datafication is the process of turning user activities and behaviors into data that can be analyzed for insights. Netflix viewing habits feed the pipeline, which trains the algorithm, which then instantly alters the interface to improve future recommendations. This network graph shows how adding more users increases the platform's utility, a phenomenon called network effects. The AI factory also generates learning effects, where massive data volumes improve the algorithmic accuracy for every single user. Traditional firms cannot compete against a platform capturing both network and learning effects at once. These effects create a self-reinforcing moat. The firm with the most data builds the smartest factory, which attracts even more data. Digital hub firms are using these AI factories to trigger collisions in retail, healthcare, and even the automotive sector. But frictionless scaling has a dark side. The same architecture that scales efficiency infinitely also allows a firm to scale errors instantly. Algorithmic bias is a significant threat. This occurs when selection and labeling biases in the data pipeline inadvertently automate and amplify systemic discrimination. Algorithms optimized purely for engagement can also amplify misinformation, leading to severe consequences in public health. This has led to increased regulatory pressure. Governments are holding tech leaders accountable for the health of their ecosystems and the information they disseminate. Because the AI factory operates without human friction, a localized data flaw becomes an immediate global liability. The role of human leadership changes when the firm's critical path is automated. Management must shift its focus from executing routines towards designing the architecture, setting strategy, and managing the ethics of the system. This requires multidisciplinary governance. Technical engineers alone cannot solve the ethical challenges of enterprise AI. It requires leadership focused on culture and